If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial will cover graphing the cotangent function. That is right. First of all, go ahead and subscribe to the YouTube channel Fort Bend Tutoring. Go ahead and click on that bell icon so that you can be notified when we are uploading new and fresh content for you. Oh, yes. And let's go ahead and take a sneak peek at the problems that we'll be doing in this tutorial. That's right. We have number one, f of x equals to cotangent x. That is the parent function of the trigonometric function cotangent. Yeah. I have problem numbers 2, 3, and 4. Go ahead and take a gander. At the different variations on the function that we'll be taking a look at as far as graphing the cotangent function. Okay, And here I have some lovely information for you to read over and retain. That's right. So with cotangent, f of x equals to cotangent of x, this function equals to 1 divided by tan of x. That's right. It is the reciprocal function of tangent. So make sure you check out our tangent video as far as graphing is concerned. And our domain for cotangent is x is such that x cannot equal to n times pi, where n is an integer. The range for cotangent is negative infinity to positive infinity, all real numbers. And the graph is symmetric with the origin, so the function is an odd function. Therefore, cotangent of negative x is equivalent to the opposite of cotangent of x. Yeah. Good stuff to know. Hey guys, just wanted to give a quick shout out to Carrie Ebert and her entire family at the Crafty Family Company. This family ran company specializes in personalized gifts, just like the personalized wooden blocks that you see right here in this video. So go ahead and check them out at craftyfamily.com, and you'll be seeing these customized blocks, guys, going forward in all of my videos. So now we have the expanded form of our function cotangent, where we have isolated the values of a, b, c, and d. And this expanded form is what we can use to help us with transformations. That's right. So the absolute value of a is the vertical stretch. Here we have our period, which is equal to pi divided by our b value. Our phase shift, aka the horizontal shift of the function, is c divided by b when it's in this form. And your vertical shift is d. Your increments, most important to me, is the period divided by 4. Go ahead and take a sneak peek of that. There you go. So it's the period divided by 4. There you go. That's what you need. Continuing on. The next thing is how to go about finding the vertical asymptotes. This page describes the different techniques that you can use to find the two equations of the vertical asymptotes that they may ask you for, or an infinite number of vertical asymptotes. So either form is correct as far as the questions that you may find in your mathematics classes. All right, let's continue on. From here, we have number one, the parent function. F of x equals to cotangent of x. So the first thing that we're going to figure out is what is the period of this function. That's right. And with this period here, which is equivalent to pi divided by b, our b value in this function is 1. Yeah, that's right. The coefficient on the variable x is 1. Therefore, our period is the quotient of pi and 1, which gives me a period of pi. Yeah, just like that. In addition to this, we may want to go ahead and find out what the vertical asymptotes are. Yeah, that's important. So with the vertical asymptotes, our first equation that we'll use will be our quantity inside the parentheses here, which is x in this case. We'll say that x equals to 0. That'll be one of our vertical asymptotes. And then in order to find the other, you'll set that same quantity of x. You'll set it equal to pi. This is where the function will be undefined at 0 and at pi, which causes these vertical asymptotes to occur. So remember that if you're going to just graph one period of cotangent, these are the only two equations for the vertical asymptote that you'll need. However, However, remember that other form I gave you on the previous page, that may help you if they ever ask you what are all of the equations that will create a vertical asymptote in this function. All right. And just so that you'll know, for today's strategy that I'm showing you, I'm just going to be using the two equations for the vertical asymptotes there. Okay, so here we go. The next thing I want to keep up with is the increments. See, this is going to help me with my ticks for my x-axis, as well as how to come up with the x values that I'll need to use for this function. So for starters, I know that my increments will be the period, which is pi, divided by 4. So I'll have increments of pi divided by 4, and I'll be starting my XY chart with 0 and ending my XY chart with pi, noticing that the difference between 0 and pi is our period, which is pi. There you go. All right, so let's see how that works out. For starters, on my XY chart over here, I'm going to go ahead before I forget. I'm going to write down the fact that I'll begin with 0 and I'll end with pi. With the period being pi over 4, we'll be adding this value of pi over 4 to each of our x values until we get to pi, which means that my second value of x is going to be pi over 4. And then my third value of x is going to be pi over 4 plus pi over 4, which is pi over 2. All right. And then adding pi over 4 again, we'll end up with 3 pi over 4. And then finally, we'll wrap up, of course, with pi. So we end up with 1, 2, 3, 4, 5 values of x that we'll be using for our xy chart. Moving back to our attributes for the cotangent function, the vertical stretch is going to be the absolute value of a. My a value is 1, and therefore the absolute value of 1 is 1. Remember that when we did our period earlier, we ended up with a value of pi for our period. And the equations for our vertical asymptotes were the equations x equals 0 and x equals pi. Your vertical shift is 0 because our d value is 0 here. So it's good to keep up with that. And if you want to keep up with your phase shift is 0. Okay, because we don't have any c values in this function here. So the next thing we'll want to do is come up with our y values. Your y values are going to be the result of you plugging in each of these x values into the cotangent function. So starting out, we should know off the bat that at 0 and at pi, you're going to end up with the function being undefined because you're dividing by sine. Remember with your quotient identity that cotangent of x is equivalent to cosine of x divided by sine of x. So everywhere sine equals to 0, the function will be undefined because you can't have 0 in the denominator of a fraction, right? Or you could say you can't divide by 0. Either way, it's going to be undefined. Then plugging in pi over 4. Well, pi over 4 is 45 degrees. At 45 degrees, your x and y values are equal to each other. And remember that cotangent is the quotient of these values. And if you forgot how to find out your trigonometric values, check out this video right here. There you go. So I'll be dividing my x value by my y value. So at 45 degrees, both values are 1. So 1 divided by 1, it's 1. Yeah, the answer is 1. There you go. Then plugging in your value of pi over 2 into the cotangent function. At pi over 2, we're at 90 degrees. And cosine is 0 at 90 degrees. And sine is 1 at 90 degrees. So therefore, the quotient of 0 and 1 will give you a result of 0. Finally, at 3 pi over 4, that's 135 degrees, by the way, cotangent is going to have a result of -1. So here we have our 5 values that we can use to plot our function. So red, box it. That's right. Let's go ahead and box up our vertical stretch here. We're going to box up the period. We're going to box up our 2 vertical asymptote equations and our vertical shift, as well as the increments and our phase shift. All important information. As far as graphing our cotangent function right now, we're going to go ahead and start by indicating where our vertical asymptotes are. We know that we're going to have a vertical asymptote at x equals 0, aka the y-axis. So I'm going to do a dash line right here to show what my vertical asymptote is. And then I'll also have a vertical asymptote at x equals to pi. Well, that's going to be right here. All right, with a dash line. There we go, there we go, there we go. Then plotting our other 3 points. At pi over 4, I'm going to be at 1. At pi over 2, I'm going to be at 0. And at 3 pi over 4, I'm going to be at -1. And with these 3 points, we will have the following graph of cotangent. Just like that. All right. So this is going to be a full period of cotangent, what you see before you right now. And that completes the graph of problem number 1. Yeah, this is the parent function. Check it out. Not bad at all. Let's see what we have next. In problem number 2, we have y equals cotangent of the quantity 3x plus pi. That's right. So the first thing that we're going to find is our period of the function. And remember that your period is the quotient of pi and the coefficient b. So we'll end up with pi divided by 3, which is pi over 3. There you go. There's your period. And we'll go ahead and find out our vertical asymptotes next. Now, when finding the vertical asymptotes, you'll take the quantity that you're taking the cotangent of. In this case, this 3x plus pi. And you'll set the first one equal to 0. And then for the second one, you'll have 3x plus pi. This equals to pi. So set that quantity first to 0. And then for the second equation, you'll set it equal to pi. Then you want to solve for x in each. And the benefit of solving this first equation for x is that the value that you end up with is going to double as the phase shift. So here our vertical asymptote equation is x equals negative pi over 3, but your phase shift, the horizontal shift here, is also negative pi over 3. Okay, so you get a 2-for-1 special there. Now for the second vertical asymptote equation, you're going to subtract pi to both sides, just like so. So I have 3x equals to 0, and then dividing both sides by 3, you'll have x equals to 0. So that's your second vertical asymptote. And then as we find our increments here, and let's not forget about the increments. I live for the increments, thank you. The increments is going to be your period of pi over 3 divided by 4. What does this give you? It gives you pi over 12. Yeah, so our increments are pi over 12. Red box it. Yes, we want to protect our answers before we move on. We don't want these answers to get lost in the shuffle here. Okay, so protect your results. There you go. Red box it. So now that we have that, moving on. We know that our vertical stretch here, the coefficient is 1. It's going to be 1. Thank you. We just found out our period was pi over 3. Keep that in mind. Your vertical asymptotes are x equals negative pi over 3. And the other is x equals 0. Okay, there you go. Then your vertical shift is 0 because your d value is 0. So here we have all of our attributes for our cotangent function. And remember, we're going to start at our first value, which is going to be the phase shift, aka also the value that we found with our first vertical asymptote of negative pi over 3. And we're going to be adding to that pi over 12. That's what we're going to do. Now, you may benefit from the fact that the equivalent fraction for negative pi over 3 is negative 4 pi over 12. Okay, so as we keep adding pi over 12 to this value, we're going to get our additional x values that we'll need to use to graph our function. So adding pi over 12 to this value will give us negative 3 pi over 12, which reduces to negative pi over 4. So with the negative 3 pi over 12 value that we just left and adding another pi over 12 to it, you'll end up with negative 2 pi over 12, which reduces to negative pi over 6. And then you'll be adding pi over 12 to this negative 2 pi over 12, which gives you a value of negative pi over 12. Then finally adding pi over 12 to negative pi over 12 gives you a result of 0. Remember that our two vertical asymptotes are x equals to negative pi over 3 as well as x equals to 0. This means that we correctly calculated our x values for our graph. So we already know what's going to happen at the asymptotes, right? The function is undefined. There you go. And as we plug in negative pi over 4 into the function, 3 times negative pi over 4 gives you negative 3 pi over 4 to leave you with a result after adding pi to it, pi over 4. Well, pi over 4 sounds familiar. Cotangent of pi over 4, guys, was 1, right? And then we'll be plugging in negative pi over 6. Well, 3 times negative pi over 6 gives you a negative pi over 2. And negative pi over 2 plus pi is pi over 2. And cotangent at pi over 2 is 0. Plugging in negative pi over 12, you'll have 3 times negative pi over 12. That gives you negative pi over 4. And therefore, negative pi over 4 plus pi gives you 3 pi over 4. Well, cotangent at 3 pi over 4, aka 135 degrees. Didn't we just find out that that value was negative 1? See, if you keep with this strategy, your y values are always going to be equidistant and more than likely give you this pattern here, all right, or a multiple of it. Now, mind you, that is depending on the function, and we'll see other examples as we move forward, but you should see some type of pattern there. Now, that being the case, let's go ahead and graph this. We're going to be at negative pi over 3, that's right here, and we're going to make our first asymptote. So we have an asymptote right there. We'll have our second asymptote at 0. Like so. And then plotting our points at negative pi over 4, I'm going to be at 1. Then at negative pi over 6, I'm going to be at 0. Also at negative pi over 12, I'm going to be at negative 1. And so here we can go ahead and graph our function. And once again, this is going to be one period of cotangent. And if you're asked to find multiple periods, you could just repeat this process either to the left or right of this existing graph. So for instance, if I wanted to show another period of this function here, I can just recognize that for every 1, 2, 3, 4 ticks, I'm going to have a vertical asymptote here. Okay, and then my points will repeat within the 2 vertical asymptotes. So I'll have a point here, I'll have a point here, and I'll have a point here to once again have my cotangent graph between the 2 vertical asymptotes and done. All right, that takes care of problem number 2. Now, I want to remind you guys, did you know that you can get a tutorial with me, Mr. Witt, online using FaceTime or Skype? Yeah, that service is available to you. So all you have to do is set up a paid online tutorial today at Fort Bend Tutoring, and that website is going to be tutormemath.net. There you go. So at that website, I'll put a link right here. You can go ahead and set up a paid online tutorial today with Mr. Witt, your boy. You know what I'm saying? You and me together with math. All right, continuing on. Here in problem number 3, we have f of x equals to cotangent of 2x minus pi over 2 minus 1. Right. Well, my process is going to remain the same. I want to start out by finding out what this period is. And the period is going to be pi divided by b, where in this case, my b value is 2. So I end up with a period of pi over 2. Just like that. And so next I want to find out what my vertical asymptotes are, the equations that is. And so we'll have 2x minus pi over 2 equals to 0, while the other equation will be 2x minus pi over 2 equals to pi. And from here, we can begin by adding pi over 2 to both sides of the equation. I'll bring down 2x, which equals to pi over 2. And then once you multiply both sides by 1/2, let's get a little clever here. You'll end up with the following equation. You'll have x equals to pi over 4, just like that. And remember, this is going to also double as the value for our phase shift, pi over 4. And in our second equation, we can add pi over 2 to both sides of the equation. And we'll have 2x equals to 3 pi over 2. Okay, so that's what we have there. And then by dividing both sides by 2, or as I did in the previous equation, multiplying both sides by 1/2, I think that's going to be safer for all involved, we'll end up with x being equal to 3 pi over 4 for our second equation for the vertical asymptote. Red box it. So I got a red box for my period, also for my equations for the vertical asymptote, which are going to be x equals to pi over 4 as well as x equals to 3 pi over 4. We have a phase shift of pi over 4, and let's not forget the increments, right? I like to keep up with the increments. So our increments are going to be the period divided by 4. So if I have pi over 2 divided by 4 here, this will give me a result of pi over 8. Red box it. So this is what I'll be adding to each of my x values as we move through this process. All right, so what did we learn here? Our period, pi over 2. We also have a vertical stretch of 1. We have vertical asymptotes that are at x equals to pi over 4 and x equals to 3 pi over 4. Okay, those are going to be the two equations for the vertical asymptote. Our vertical shift here is -1, so that's different. And we had increments of pi over 8. Okay, and a phase shift, by the way. The phase shift is going to be pi over 4. Okay, so we didn't want to forget that. Now, the x values that we'll be using. We're going to be starting at pi over 4, like so. We're going to be ending at 3 pi over 4. All right, and we'll be adding increments of pi over 8 to our starting value of pi over 4 here. So pi over 4 is equivalent to 2 pi over 8, so our next one will be 3 pi over 8. Okay, then adding pi over 8 to 3 pi over 8 will end up with 4 pi over 8, which is pi over 2. And from 4 pi over 8, we'll add another pi over 8 to get 5 pi over 8. Just like that. And of course, with the 6 pi over 8 that would be next, we would reduce that to get our 3 pi over 4, which will give us all 5 values for x for this function. So now we'll find out what our y values are by plugging in our x values from the xy chart. So remember that this pi over 4 value is where our asymptote is going to occur. So this is going to be undefined. Same thing occurs at 3 pi over 4. So we don't necessarily need to plug these values in. We know what's going to happen there. However, we can begin with 3 pi over 8. So 2 times 3 pi over 8 is going to give you 3 pi over 4. And then 3 pi over 4 minus 2 pi over 4 is pi over 4. And cotangent at pi over 4 is 1. However, this time we need to also subtract 1 from that value. So 1 minus 1 gives us a result of 0. Remember, there is a vertical shift down 1 unit. So that's going to affect our y values that we've gotten up to this point. Now, plugging in pi over 2, 2 times pi over 2 is pi, and pi minus pi over 2 is pi over 2. Cotangent at pi over 2 is going to be 0. And 0 minus 1 gives you a result of -1. Now, plugging in 5 pi over 8. 2 times 5 pi over 8 is 5 pi over 4. 5 pi over 4 minus 2 pi over 4 will leave you with 3 pi over 4. And cotangent at 135 degrees is -1. However, subtracting 1 from that value gives you a result of -2. And now we have all 5 values that we can use to graph our cotangent function. We'll begin with the vertical asymptotes. So I'll have a vertical asymptote at pi over 4. It's going to be right here. We also have a vertical asymptote at 3 pi over 4. That'll be right here. And we have points at 3 pi over 8, 0. It's going to be right there. We have a point at pi over 2, -1. Gives me a point right here. And we also have a point at 5 pi over 8, -2, which gives me a point right here. So our graph will look like this. Like so. Okay, so it's just been shifted down 1, all right, as well as our horizontal phase shift, which brought us over to pi over 4 in the first place. Yeah, and this is a full period of our cotangent function for problem number 3. There you go. Good examples, huh? Let's keep it going. Good examples. I appreciate you guys hanging out with me. Always a good time with you. All right, so here we have problem number 4. This is going to be y equals to negative cotangent of x minus pi over 6. If I were keeping up with my transformations, guys, I would know that I would have a vertical reflection, aka a reflection across the x-axis. Also, I know I have a horizontal shift of pi over 6 to the right, if I were keeping up with transformations. Okay, so that's another strategy, right? So now what I'm going to do, I'm going to find out the period first. And recall that the period, oh, that's an ugly P. We're going to have to fix that. We're going to have to fix the ugly P. And look at that. Is that not a better P? Let me know in the comment section if this is a better P. Appreciate that. So you'll have the period, which equals to pi divided by B. Your B value is 1 in this case. All right, so we're going to have a pi value for the period. Okay, the period's length is pi units. Yeah. And then as far as our vertical asymptotes are concerned, you'll have to set the value that you're taking the cotangent of to 0. So x minus pi over 6 equals to 0. And you'll also set that same quantity of x minus pi over 6. You're going to set it equal to pi. Just like that. Go ahead and add pi over 6 to both sides of the equation for the first vertical asymptote, and you'll get x equals to pi over 6. And for the second equation, while we'll be adding pi over 6 to both sides, you should know that pi is equivalent to 6 pi over 6. So 6 pi over 6 plus pi over 6 gives us 7 pi over 6. Isn't that cute? And now that we have our equations for the vertical asymptote, let's go ahead and realize that the phase shift is also going to be pi over 6, and that when it comes to your increments are going to be the result of taking the period, which is pi, and dividing it by 4. So your increments are going to be pi over 4 in length. There you go. Red box it. That's right. So I've got a red box right here. My vertical asymptotes, get both of those in the red box. I'm going to put my phase shift in the red box, and I got my increments in the red box, just like that. Yeah. Let's go ahead and move on. We have a vertical stretch of 1. Okay. Yeah, it's the absolute value of a that we want. So we would have an a value of -1 here, like so. The absolute value of that is 1, so your vertical stretch is 1. Your period, once again, is going to be pi over 1, which is pi. We already know that our vertical asymptotes are x equals pi over 6 and x equals 7 pi over 6. And your vertical shift here is 0. My increments is going to be pi over 4. And my phase shift is pi over 6. Okay, we'll begin with pi over 6 on our XY chart, and we'll be finishing up with 7 pi over 6. Just like that, guys. And now we'll be adding pi over 4 to every value to find out the other 3 values we'll need for our XY chart. We know that our common denominator for 4 and 6 is 12, so we may want to keep in mind that this is equivalent to 2 pi over 12 here, okay? So adding our equivalent increment of 3 pi over 12 to each value of x may help us out here. So 2 pi over 12 plus 3 pi over 12 gives us 5 pi over 12. Okay, then 3 pi over 12 plus 5 pi over 12 gives you 8 pi over 12, which reduces to 2 pi over 3. Like so. Then adding 3 pi over 12 plus 8 pi over 12 gives you 11 pi over 12. And then finally, when you add 3 pi over 12 plus 11 pi over 12, you'll get 14 pi over 12, which reduces to 7 pi over 6. We know that at the asymptotes, it's going to be undefined. And plugging in 5 pi over 12 into our original equation here, you'll have 5 pi over 12 minus 2 pi over 12 gives you 3 pi over 12, which reduces to pi over 4. And we know that cotangent at pi over 4 is 1. However, the opposite of 1 gives you a result of -1. Then our 2 pi over 3 value, all right, that's equivalent to 4 pi over 6. 4 pi over 6 minus pi over 6 gives you 3 pi over 6, which is pi over 2. Cotangent at pi over 2 is 0. The opposite of 0. It's 0. There we go. Plugging in 11 pi over 12. 11 pi over 12 minus 2 pi over 12 gives you 9 pi over 12. 9 pi over 12 reduces to 3 pi over 4, where our cotangent value would be -1. However, the opposite of that value is +1. So we get a result of 1 here. Okay, guys, let's go ahead and start with our vertical asymptotes. So I'm going to start by plotting my vertical asymptote here. Beginning at pi over 6, I have a vertical line right here. And 7 pi over 6 is going to take us off the graph. Well, who set this up? Let me go ahead and fix this. All right, well, this is much better now. Okay, so now we have room. And so our second vertical asymptote is going to be right here at 7 pi over 6. All right, great. Now plotting the 3 points that fall between these two vertical asymptotes. I'll have a point at 5 pi over 12 and -1. That's going to be about right here. Okay. Then we'll have a point at 2 pi over 3, 0. That gives me a point here. And we'll also have a point at 11 pi over 12 and 1. That gives me a point right here. So because of the vertical reflection, we'll have a graph that looks like this. All right. Just like that. And it's a little zoomed in for this graph because of our increments and things like that and the way I did my text, but You know what I'm saying? It's correct. It's correct. Thank you. It's right. So, hey, that does it. This is our graph for problem number 4, guys. We made it to the end together. Go ahead and click on thumbs up just because you made it to the end. Congratulations, guys. And do not forget to subscribe to our YouTube channel, Fort Bend Tutoring. And as always, please like, comment, and subscribe. And if you're able, please donate, as that helps us bring you more videos from Fort Bend Tutoring and myself, Mr. Witt. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.